So in this video, I'm going to explain how to find limits of composite functions. Honestly, I have not seen another YouTuber that explained this well, especially when it's one-sided limits of composite functions. It gets confusing, and I have not seen another YouTuber actually explain how to do it. Okay, so I'll try my best to explain and try to bridge those gaps if you came from those videos. This video should be helpful for if you're taking AP Calculus. This is a very common topic that they ask when you're first learning about limits. And if you're taking calculus at a community college or university, honestly, I don't think this is too important, to be honest. For the one-sided ones, I should say. But the two-sided limit for sure is important, no matter what school you go to, whether you're taking this at AP Calc or calculus at a community college or at a university level. All right, so let's begin. So the big question is, how do we evaluate the limit as x approaches to a f of g of x? This is a composite function because g of x is composed inside of f of x, okay? So let's quickly recall how composite functions work. So suppose we have f of x equals x squared. G of x is x minus 1 quantity squared. How do we find f of g of 3? Well, we kind of think, let's recall order of operations. We have to do what's inside the parentheses first, and the innermost kind of, right? So the innermost function is g, so we got to find g of 3 first. Okay, so what's g of 3? That's just 3 minus 1 in parentheses squared, which is 2 squared, that's 4. Okay, and then we take this 4 and we plug it into f. So f of g of 3, we just found g of 3 is 4. So we replace that g of 3 with 4. So what's f of 4? That's just 4 squared, which is equal to 16. Okay, so we go into the inside first, and then we plug that output of the inside function into the outside function. Okay, so here's a more conceptual way to look at it. Okay, so if we have g and f like before, f of g of x, okay? As I was saying, if we have some input like x is equal to a, we pass that input first into g. Okay, so this is a kind of a black box, a big system, okay? But what's happening inside this big system is, well, when you insert x is equal to a, it first gets passed into g. It's good that g is going to do something and output something, g of a. Okay, like we did up here, g of 3 was what we found first, right? So it's going to output some g of a. And this output of g gets passed as the input to f. So this g of a becomes our x again and gets passed into the system f. And then this f will output f of g of a, kind of what we did up here. Okay, so this I like to represent. This is a very typical engineering way to represent block diagrams and all that, passing things in and out of stuff. Okay, so this is helpful, in my opinion, to explain those one-sided limits that are coming up. Okay, so let's keep this in mind if this helps you out. So once again, this is a big system, f of g of x. What's happening inside is if we input we input x is equal to a into the system, it first gets passed into g does something to it, and the output of g becomes the input f, and the f does something to that, and then you get your final output. All right. So limits of composite functions work very similarly if we try to understand how those composite functions work with that block diagram I just went over, okay? So this is the general strategy that always works to find limits as x approaches to a f of g of x, okay? So we first find the limit of the first function or the inner function, limit as x approaches a, g of x, let's say is equal to k, okay? And then we're going to use the limit of the first function as the x value to approach for the next function, okay? So we approach k for g, so we're going to use that as the inputs in a sense to f. So we're going to approach k for f of x, and that if that approaches L, then we say limit as x approaches a, f of g of x is equal to L. So I'll go over the block diagram representation in a bit, okay? Actually, let me go over that first, and then I'll go over the third point, okay? So kind of, we'll go up here again. We pass it into G first, and the output of G gets passed into F. And that becomes, the output of F becomes the final output. So it's very similar here. We let X approach A, the original A first, for G. it's going to, let's say it approaches some k, okay? And then we're going to let x approach k for f. See how this input gets kind of passed into g, and that becomes some output, and that output becomes the input of f, kind of the same way if we understood composite functions like in the other block diagram, okay? So I'll go over some examples in a bit to hopefully solidify this understanding, okay? Excuse me. Now let me explain. Well, what if this first limit does not exist? That's this third point. If limit of g of x as x approaches a does not exist, then the whole limit doesn't exist. Because you can imagine from this understanding, how do you pass in x approaches does not exist? It doesn't quite work, right? So that's why the whole limit would not exist. That's what I was trying to say in this parentheses over here, okay? So this, if we understand it like this helps us to find those one-sided one-sided limits. And this is where I have not seen a YouTuber explain this well at all. They just say, since you're approaching from the right, we look looking from the right, looking upward or up to down. And then if you approach from the left, you look down to up, something like that. And they don't explain why. So I'll explain why in a bit. But let's go back again to this understanding that let's say that if x approaches a for g of x, it approaches only from one side. We have to pass that one-sided limit as the quote-unquote input to the next function f. Okay, up here was two-sided, but over here is one-sided. Okay, so we got to pass that continuously to the next function. Okay, so it doesn't matter if it's from the right or from the left, we got to pass it into the next function. Okay, and this is where it's a typical trick question that if you approach from both sides, you could get totally different limits. Okay, so let me explain in a bit with examples. Okay, so let's go over some examples now to hopefully solidify the understanding. Okay, so hopefully you can see this. Let me just try to zoom in a little more. Okay, so we're asked to find the limit as x approaches 2 p of q of x. P of x is this function, q of x is this function. Okay, so let's go through the process. You want to find limit as x approaches 2 of q of x first. Okay, so as x approaches 2 of q of x, this is q of x. It approaches 4, right? As x approaches 2 from both sides, we are approaching the value of 4, a y value of 4, right? So now, this is where a lot of students get it wrong. Let me even scroll down. So we found this, right? Limit as x approaches 2, q of x is 4. Now, a lot of students will just say that limit as x approaches 4 of p of x does not exist, because as we approach from the left, it's 4. As we approach from the right, it's 8. They don't match, does not exist. This is not correct, though. Okay? So we cannot blindly just, as I said, drop this one-sided limit. And now let's go back. We notice that as we approach 2 over here, right? We're approaching it from values greater than 4. Okay, so this is again where a lot of YouTubers just say that as you approach 4, we're approaching from above, so you are going to approach from the right. And they don't connect the dots of why when you approach from above, you approach from the right. Here's my explanation, okay? So as x approaches 2 q of x, as I just said, we're approaching 4 from above, but why is it 4 plus 4 from the right? Let's understand it that we're approaching 4, but it's always values bigger than 4. So like 4.01, 4.001, 4.0001, so on and so forth. What's the limit notation for values a little bigger than 4? That's 4 plus. Because remember, when we approach 4 from the right, from the tabular method, if you remember back when you first learned limits, you go like 4.1, as I just said, 4.01, 4.001, 4.0001, so on and so forth, right? So when it's approaching from above, it's approaching from values greater than 4. So when we approach from the left or right, it's approaching from the right because from the right, it's values greater than 4. That's how we connect the dots. Again, I have not seen a YouTuber that explained it at all. So that's hopefully helpful if you're trying to understand why. And honestly, when you understand why, it's more likely that you remember that to do it correctly next time instead of guessing 50% chance. From above, is it from the left or right? I really don't remember. So if we have this understanding that it's approaching values greater than 4, it's a much higher chance that we connect the dots that 4 plus means values greater than 4, okay? Anyway, so since it's values greater than 4, we approach P from the right as a result. So that's why it's equal to 8. So let's look back, approach from the right, it's equal to 8. And that's the answer. Okay? Again, it's not correct to just blindly like, oh, it approaches 4, so we approach 4 from here, and does not exist. Not correct at all. This is how they trick you. Okay, let's go with example 2. Limit as x approaches 3, p of r of x. So we have the same function p, but now we have this r of x, okay? So let's go over the wrong way again first. If we approach x is 3 for the inner function r of x, looks like it's approaching 4, right? And then let's go to p as x approaches 4, does not exist. Doesn't work like that. Okay, here in this case, notice that as we approach 3 for r of x approaches 3, we're approaching still 4, but values from values less than 4. So like 3.9, 3.99, 3.999, 3.9999, so on and so forth, okay? So what does that mean? That's 3 minus values less than 3, okay? So, sorry, 4 minus, okay? So we're going to approach the outer function from x approaches 4 minus, so 4 from the left. And that's 4 as a result. This is from the left over here. Let me show the whole function from the left. Okay, sorry for all the scrolling. Okay, now let's go over a way where you can do this quote unquote wrong way. This is where the special case where it works. Okay, I believe this is the special case where it works. I don't remember what my example 3 is. I'm pretty sure I did it like this. So if we find limit as x approaches 2, f of g of x, well, as x approaches 2, for g of x, we approach 1. Notice how we approach 1 from both sides. So it's not 1 plus, not 1 minus. It's neither of those. So it's just 1, no plus or minus in the superscript. Okay? So we're going to approach 1 from both sides for the outer function f of x as well. So that is 1, it looks like, right? So that's the answer. So in this case, because the inner function, we approached it from both sides, we can approach both sides for f as well, the outer function. In the other 2 examples, we were approaching the inner function from either above or from below only. So that's why the outer function, we took a one-sided limit. Okay. So how about this? F of h of x as x approaches 0. What's the limit of this guy? Okay. So as x approaches 0 for the inner function, it does not exist, right? Because as we approach from the left, it's -1. As we approach from the right, it's 2. They're not the same. The limit does not exist. Therefore, the limit of this whole guy does not exist either. Okay. Do I have a note? Here's a special case now. This is the important one that all students need to know, no matter AP calculus or calculus at university or community college. Okay, this is very common from my experience. So if we have this limit as x approaches a, f of g of x is composite function still. So if limit as x approaches a, g of x is equal to b, and f is continuous at x is equal to b, then limit as x approaches a, f of g of x equals f of limit as x approaches a, g of x, which is equal to f of b. This is really just using the definition of continuity. No difference. And this is actually why you probably learned all this stuff in the continuity section. Okay, you're just applying the definition of continuity here. Okay? Notice that this really is just the definition of continuity here. Remember what it is? If limit, so if it's just f of x, if limit as x approaches a, f of x is equal to f of a, it's continuous, right? So this is just saying that it's continuous at x is equal to b. Okay? So let's revisit example 3 real quick. The one I believe we just did. So limit as x approaches 2 of g of x, the inner function is 1. Isn't f continuous at x is equal to 1? Yeah, right? So that's why the limit is 1. F of 1, which is 1. Okay, so this is just a special case. All right, that's it for this video. Hopefully this cleared things up if you were totally confused as to, for example 2 and example 1, why when we approach from below, we approach from the left. When we approach from above, we approach from the right. Again, I have not seen a YouTuber that actually explained it. So hopefully this is helpful if you were totally lost. All right, please give this video a like if it has helped you in any way, and hopefully I'll see you in another video as well. Bye.